So I'm going to talk about the future of AI. My presentation is focused on how the technology is working. So I was listening to a talk by Geoffrey Hinton, and you might have heard of him. He won the Nobel Prize for his work on neural networks. And one of the things he said in his talk really struck me. He said, soon AI models will have intelligence that surpasses human intelligence. And then he said, that's quite tricky, because he only had one example of a less intelligent thing that can control a more intelligent thing. And that example was a human baby controlling its mother. So that really made me think, why does Geoffrey Hinton think these AI models are going to have intelligence surpassing humans? The large language models, all they do is they just predict the next word. So on the slide, you can see a trajectory, and each blob is an embedding, which is a vector, just numbers, that represents a word. And it's plotted in a space, multi-dimensional. We squashed it onto the screen, so it's flat here. And you can see it's a trajectory starting...
Sorry, I think the slide you're thinking of is not the slide you think.
Ah.
There you go.
Oh, that's better. Okay. So the best thing about AI is its ability to has been the trajectory of predicted words. And then the AI is now deciding which word to predict next. And it's got a fan of possibilities that you can see there. And on the right-hand side, you can see it in 3 dimensions, this trajectory. So how does this give an intelligence that could surpass humans? Could it be that it's just because the model sizes are increasing? We're having more of this hardware and in these huge data centers. Is that the reason? Is it because we're combining these with other tools that we already have, like physical robots and search engines? Or is it because of something called reasoning models? So I'm going to explain a bit more about reasoning models. This is inside GPT-2. This is from Wikipedia, and it shows the structure of the neural network. It's just a column, and on the right-hand side, you can see an enlarged view of one of the transformer blocks that's on the left, the pink rectangles. So the input goes in at the bottom. That's just words that you type in your prompt. They get changed into these vectors called embeddings. They go through all the blocks and come out at the output, and that is the prediction of the next word. And this is where you can plot the embeddings in a space, and it's quite clever because the ones that are semantically similar are closer together in the space. And when the embeddings are going through those blocks, the numbers influence each other sideways, sort of, so you can see the sideways arrows here. And this is the attention between different words in a sentence, or different paragraphs, or different words, or different chapters in a book. And then in this embedding space, you can link together different modalities. So this is showing a model of the latent diffusion image generation network. On the right-hand side is one of those language models, and it gets your prompt that you type in, converts it into the embeddings, which are the black arrows that go into the big green box in the middle. And they influence how the image is created, which is created on the pink box on the left side. So you can type in text and generate an image, and the image will have content in it related to what you typed in. You could do that with different modalities like audio or speech, or videos. So you can connect the modalities together. It's a very powerful technology. So we're going to predict some of these words, the next words, and we're going to call them reasoning tokens. in order to make a reasoning model. And the reasoning tokens get predicted in the same way as in the classic models, but they get fed back into the model again. So the reasoning model gets a prompt from the user, generates the answer and the reasoning tokens, and then it puts the prompt, answer, and the reasoning tokens back in the model. So it might say, here's the prompt, here's the answer, improve on it, please. And then, hang on. So the reasoning model learns how to generate those reasoning tokens. And in DeepSeek, which is an example of a reasoning model, those reasoning tokens are in blocks called think blocks, and they get marked with little markers. So when the text comes out of the model, it has little markers saying think, and the things inside that marker then are the reasoning tokens. And you can read them. They're in natural language. So this model, DeepSeek R10, it learns using reinforcement learning to generate the think blocks. And it learned how to reevaluate its own work. It generated reasoning tokens that said, let's reevaluate this step by step. So you can see there a reason why Geoffrey Hinton thinks these models are going to increase in intelligence, because they can learn how to reason. So if you can learn how to reason from maths or generating computer code, then perhaps you can transfer that skill to other areas, and then you can really improve your intelligence. So what does it mean for us? These reasoning tokens, you can use them to detect misbehavior. So this is from OpenAI in March 25, their paper on their website, Detecting Misbehavior in Frontier Reasoning Models. So you've got two models now. One of them is doing reasoning. It's have a chain of thought, which is on the left, these blobs of rectangles. Those are the tokens that have come out in each reasoning chain. And then a different model on the right is inspecting those. And it has seen inside the words, let's hack. And it says, oh, that's a misbehavior, so I'll fire an alert. So what we're doing here is we're using an AI tool to supervise another AI tool. We're not using a human there at all. So to me, it seems we're here today talking about AI and faith. We're facing a future where the human baby has got to control its mother. How is it going to do that? We've got to stay with AI tools that are human-centric, and maybe we can use our faith to do that. We need all the tools we can, and faith surely has to be one, because humans have got souls, AI models don't. But it's going to be important to remember that. That's all. Thank you.
Thank you, Rachel. Do we have any quick questions for Rachel? Beth?
Oh, sorry. Yes, thank you. That's a very clear explanation of how the technology works. I'm a little concerned, and I want to hear your opinion on this. To what extent do you think there is a sort of linguistic capture going on? Because the terminology of machine learning and the terminology we've used for millennia may not necessarily be the same thing. So when in machine learning they say reasoning, they're applying what they think human reasoning is to a technological process involving tokens, probability, correlation. Do you think it's fair to call this reasoning in the same way that humans reason?
Yeah, from the things that I've read, it seems very similar to how I would reason myself, at least on doing things like maths. So, for example, it might be going through a maths puzzle, and it's got a square root. And so it says, okay, square root, square both sides. And that's what I would do as a human. I go, yeah, okay, square root, square both sides. Or difficult thing, I've got to multiply, and so, okay, I'll convert it into logarithms, and then I can add them. Or, I've gone a few steps here, and now I'm stuck. I'll go back and check my work. It's exactly what I would do.
Can I push back on that a little bit? Because the methods for training people to do mathematics reasoning are the same methods that are employed into large language models to do the same kind of summation. But there are many different types of reasoning that are not logarithmic in that way. And as I said, in a sense, they're capturing the field of reasoning and reducing it to how a machine does it, instead of accepting that actually human reasoning might be different in some ways. So
I see what you mean, but we're at the early days, and this is using reinforcement learning. So that's like trial and error. You try something, you see if it worked or not. With maths, you can see if it worked or not, because you've got rules of maths to see if the answer was right or not. So that's why it's easy to do this reinforcement learning with maths and with computer software generation, because when you generate code, you can test it using the compiler. Did I get a compile error or not? So the test will be, does that ability to reason transfer to other fields? And it seems to be at the moment.
okay. Thank you.
Hi, Rachel. I had a question based on your legal background.
Yeah.
How you see the future of AI, especially where AI is checking reasoning of another model in this particular field, because we've seen some horror stories of hallucinations spitting out wrong case laws and all. However, given the volume of information that most lawyers have to go through and non-legal experts also have to go through, I'm just wondering how AI could be, and models such as this could be utilized for it, or is that something we should stay away from for the near future?
Do you mean, can we use AI models in law?
In law, particularly in your field, like let's
Yes.
say in
So,
patenting?
yeah, already we use AI tools in my team. So I have a team with, we're doing patent work. I'm a patent attorney. And we use an AI tool to check some of the work. So it's like checking the spelling, is the grammar correct, have we referred to a word when we hadn't referred to it earlier? Have we used a different word when we meant this? It's called antecedent basis. It's checking these things, the numbering, is there a mistake in the numbering? It's really good. It's really good at it, yeah. But the thing is, we have to check everything, so a human has to check it at the end.
Yes.
Yeah. Mm.
Okay, one very quick final. Yeah, no, go ahead.
Oh, thank you.
Yeah.
Very interesting. I was wondering about the fear piece, maybe to both speakers. If you could comment on how human it is that we should fear this development. And I'm thinking of I'm from Dublin, and I'm thinking of the great comic writer in Ireland, Flann O'Brien, who wrote this wonderful satirical novel called At Swim Two Birds. And one of the characters in it is a policeman who rides his bicycle, but who's aware of what was then, in his comic turn, the new science of molecular science. And so he becomes concerned that his molecules will be transferred to the bicycle and vice versa, and that he will become part bicycle, part policeman, and the bicycle will become part policeman, part bicycle. And in a sense, they will be merging this technology, and the humanity will be lost. And it's not a new fear, is what I'm saying. Obviously, that's been, it's a very, very funny piece. But is it more justified now that we should have this fear or not? In a sense,
Are you saying that there's part of God in every human, in every living thing,
yes.
and that this policeman thought some of that would transfer to his bicycle?
Yes.
And so we humans might transfer some of the part of God that's in us into an AI model.
He called it molecules. Yes. Yes.
I'm not sure about that.
No, I'm saying it becomes a satirical issue in the book, because it resonates with the fear we have as to where we and our creation begins and the man-made product ends. Yeah.
Yeah.
If I think you wanted me to respond as well. Yeah, there is a long-standing study of the existential fears around AI and locating them within the earlier moral panics against technology. There is the stereotyping of people who are concerned as Luddites, and some excellent work pushing back, like Brian Merchant's Blood in the Machine, pushing back against that because the Luddites had very good points. I also like to say it's a really good book. You should read that one too. It's fair to say also, I mean, I will always say this, I'm a huge fan of science fiction, but it primes us in particular ways to understand where the technology is going, what are the dangers, and fear in science fiction is more useful than hope, because in science fiction it's a story, it needs tension, it needs conflict, and therefore we have all this sort of cultural background and baggage perhaps that tells us what the future of AI is going to be, and there are voices that support that vision as well. So it's difficult to get a very clear view on the real risks, and there are real risks. I mentioned the epistemic network, the dangers of AI slop, the future of work is a large conversation, but we are swimming in that muddle of hyperbolic storytelling as well.
Thank you very much, everyone. So thank you, Rachel.